Okay, this is finding the quadratic equation part 2, and what we're going to look at here is what if we don't have the vertex, but maybe what we have are 3 points. Now these 3 points can either be written out the way I'm going to write them out here. So the 3 points that the parabola goes through might be 1, 3, and we got 5, 3. And we've got 7, 9. Now, I wrote these points out, but they could also just as likely be that you have a graph. So maybe they give you the graph of a parabola, and you have to figure out these points by looking at the graph. So that's no big deal. I mean, you just look at the picture and you say, oh, okay, I can spot 3 points that are clearly on this, this parabola. So those are my 3 points. Now what I'm going to do is I'm going to sketch a graph. And so I'm just going to write out what the steps are here. This is about 4 steps to getting the equation. And I really recommend if you draw a sketch, it really helps kind of guide you. You really get kind of a framework, good starting point, and so on. So I'm going to just clear the screen here. And I'm going to boot up the grid here. So we've got the grid. And what we're going to do is we're going to plot the points that we're given. So the first point was 1 to the right and up 3. So that's that point. And then 5 to the right and up 3. And then we've got the point 7 to the right, which is here, and I've got to go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're almost right at the top there. All right, so this is kind of the points that we're given. Now, I have a rough idea the parabola probably goes something like this, but I really don't know exactly how far down to draw where the curve is. But here's what I can tell you. Because of the symmetry of a parabola, these 2 points here basically tell me that my axis of symmetry must be right through x equals 3. So that tells me, oh, if that's the axis of symmetry and that's going through a value of 3, then if I take my basic equation, here's what I've got. So I've got y equals, I don't know a, but I do know where I've got to be as far as this little number tucked in with the x. Now let's finish this up with the plus k. So what number do I have to put in here? Well, I want to make sure that if I plugged in a 3 where the x is, this would turn to 0. So I want to make this x minus 3. So that, again, if I plugged a 3 in to here, I'm going to turn this into 0. So I've got one part of my equation figured out by just drawing the picture and analyzing where the axis of symmetry is. So that's basically step 1. Now step 2, so I'm just going to see if I can do part of this down the side here. Step 2 in this is we're either going to use the point on the left or the point on the right, and that's going to help us to get an expression for k. So we're going to use one of these points. It doesn't really matter which one. Maybe I'll use the one on the left, so maybe I'll use the point 1, 3. And I'm going to plug the coordinates in for the x and the y. So that gives me this. I've got 3 equals a, which I don't know, and then for the x, I'm going to plug in a 1. So 1 minus 3 squared plus k. So I'm going to simplify this a little bit here. That gives us 3 equals, and this is going to be negative 2, but I'm going to square it. So that's going to become a 4 times the a plus k. And the goal in this step 2 is to isolate the k. So I'm going to subtract the 4a to the other side. Okay, so we have that k can be expressed as 3 minus 4a. Now that's the end of step 2, and I'm kind of running out of room here. So what I'm going to do is clear the screen and start step 3. Okay, so this is now step 3. Step 3 is we're going to use the other point, the extra point, which I call the extra point. It's the one that wasn't involved when we identified the axis of symmetry. Okay, it's the one that was kind of the odd point out. Okay, so we're going to use the extra point. In this example, the extra point was the 7, 9. Okay, and here's what we've got so far from our previous works. I kind of want to rewrite it here so you can clearly see. We came up with an expression for k, and that was 3 minus 4a. And we also had this as a kind of prototype equation. Y equals a times x minus 3 all squared, and we have plus k. So what we're going to do is this expression here, which is equal to k, we're going to substitute that in for the k at the end of this equation. So what I'm going to have is I'm going to have y equals a times x minus 3 all squared plus, now instead of putting k in here, I'm going to replace it with 3 minus 4a. Okay, now because this was plus, I don't have to put brackets around this. And so I can just write it as 3 minus 4a without any fancy brackets. Now I'm going to bring in this point with the coordinates of 7 and 9. So the y-coordinate is 9, and for the x-coordinate we have 7. Now when I'm finished writing it out here, if you look closely at what you have one equation with a bunch of numbers and one variable, which is a. This thing can be solved for a. So what do we got? We've got 9 equals, now this is 7 minus 3 is 4, okay, and 4 squared is 16. So this is 16a. Then we have plus 3 minus 4a. Now I'm going to subtract the 3 from both sides, so that'll be a 6. And 16a minus 4a is 12a. And then we're going to divide the 12 to the other side, and we might as well put it into lowest terms as well. So this is going to be 1/2. So that is now what a is. Okay. So once we have that, and that was step 3, we're going to carry on to step 4, and I might just be able to kind of, well, maybe I'll just clear the screen. We know a is 1/2, so let's keep that in mind, and we're going to use this expression here, so I just pointed out before I clear the screen. K is simply 3 minus 4 times a. So, and we know a is 1/2. So what I'm going to do here, so this is step 4, and this is called find k. Now we know that k equals 3 minus 4a. Then we also just figured out that a is 1/2. So k must therefore equal 3 minus 4 times 1/2. So that means k is equal to 3 minus 2, or 1. So finally, I can put it all together, and so here is my final equation. So it's quite a few steps involved, but they're pretty logical. So we have either you can call it f of x or y, whatever you prefer. And we came up with a is 1/2. So that's 1/2 brackets. And we had x minus 3 pretty early on, all squared. And then it turned out k is a positive 1. And so that is our final solution. And again, the question doesn't have to be that I tell you exactly where the points are. I might just give you a graph or a picture, and you would look at the picture and you could figure out 3 points right off the graph itself. And that's where we're going to stop for this section.